Hello friends, welcome to Blessed Excellence Center. Don't forget to subscribe to our channel. In our last class, we looked at introduction to de novo synthesis of purine. Today, we are going to consider the preliminary phase of purine nucleotides de novo synthesis. Your presenter remains E.B. Christian. Purine nucleotides are inosine monophosphates, that's IMP, adenosine monophosphates, AMP, as well as guanosine monophosphate, that is GMP. Purine de novo synthesis uses pre-existing ribose 5-phosphates, R5P, while the different atoms of the purine base come from different amino acids, carbon 4 oxides, as well as tetrahydrofolates. The synthesis first form IMP, that is inosine monophosphates, from where AMP and GMP are formed, and finally ATP and GTP are formed. Now what that means is that the synthesis of purine nucleotides uses ribose 5-phosphates as a starting material. Ribose 5-phosphate is obtained from hexose monophosphate shunts. Now, the only thing that is synthesized during the synthesis is the purine base that is synthesized, and then on top of the ribose 5-phosphates. So the ribose 5-phosphate is already there, formed from hexose monophosphate shunts. So as you can see in this reaction, this pathway here, this is ribose 5-phosphates. It undergoes 10 main steps and 1 preliminary step, making it 11 steps to give you inosine monophosphates, which is a purine nucleotide. Now, the inosine monophosphate undergoes 2 steps to give you adenosine monophosphates. Then it also undergoes 2 steps to give you guanosine monophosphates. So this is supposed to be GMP, that's guanosine monophosphate. Then the guanosine monophosphate is phosphorylated to give you guanosine triphosphate. Also, adenosine monophosphate is phosphorylated to give you adenosine triphosphates. Now, the preliminary phase or preliminary step of purine de novo synthesis. This is the step that prepares ribose 5-phosphates to start purine nucleotide de novo synthesis. It involves the activation of ribose 5-phosphates from hexose monophosphate shunts, HMS, by addition of pyrophosphates group PPI to form a molecule called phosphoribosyl 1-pyrophosphate, PRPP. The reaction is driven by ribose 5-phosphate pyrophosphokinase and utilizes ATP, generating AMP and PI. So this is the preliminary phase. It's actually an activation. This is ribose 5-phosphate. This is formula for ribose 5-phosphate. This is the ribose, the ribose sugar, and this is the phosphates group. The two of them constitute ribose 5-phosphates. It is called ribose 5-phosphate because the phosphate group is attached to carbon 5. This is carbon 1, carbon 2, carbon 3, carbon 4, and carbon 5. So we call this ribose 5-phosphates. In the presence of ATP, the ATP here will donate 2 phosphate groups that will be attached to this hydroxy. When it attached to this component, to this point here, it forms this other group you are seeing here. You see, this phosphate group is repeated here, phosphate. The ribose sugar is repeated, the ribose sugar, and then the phosphate group is added here, giving you phospho ribosyl 1 pyrophosphate. E is the enzyme, and the enzyme is called ribose 5 phosphate pyrophosphokinase. The enzyme is magnesium ion dependent, so it requires magnesium ion to drive its reaction. So this is actually a preliminary phase. It is not considered as one of the steps. It is a preliminary step that ushers or that prepares or that activates ribose 5 phosphate to actually start the process of purine nucleotide de novo synthesis. All right, okay, so let's see the summary of the 10 steps, the summary of the 10 main steps of purine synthesis. In our next class, we shall be giving attention to the main step in detail, but I want to give us a summary of it. Now, there are 10 main steps of the pathway, that is purine nucleotide de novo synthesis. Step 1 uses glutamine. Step 2 uses glycine. Step 3 uses tetrahydrofolate. Step 4 uses glutamine also. Step 5 involves ring closure. That is where ring closes, okay? Now, step 6 uses carbon 4 oxide. Step 7 uses aspartate. Step 8 releases fumarate. Fumarate is released at step 8. And then at step 9, tetrahydrofolate is used, that is inculcated. Finally, in step 10, nothing is added but water is released and ring is closed. So it involves ring closure. Now take note of this, that step 2, step 4, step 5, step 6, and step 7 require energy, and as such are driven by synthetase. So a reaction that requires energy or that uses ATP is driven by a group of enzymes called synthetase. So this is a summary of the main steps. In our next video, we shall be talking of the main step in detail with their structure. Thanks for watching. Do wait to subscribe if you've not yet subscribed. Share the video so that others will be blessed by it. Click on the bell, on notification bell, so I can get more updates of our video. Like the video. Do wait to drop your comments.